Welcome to today's lesson. I'm Samasaka and Dennis. Today, actually, we'll look at a topic in physics. We'll basically look at linear motion, and basically, we'll derive the equations of motion so that we can be able to use them appropriately. Because if we understand them, it becomes very easy for us actually to manipulate them and be able to apply them appropriately to ask the questions. And so we go straight to the lesson. So as I said, we are looking at the equations of kinematics for constant acceleration. And so look at the equation number one. Basically, number one is actually helps us to find the basis for other equations. So we know that acceleration is equal to the final velocity. So V here stands for final velocity minus C, initial velocity, U stands for initial velocity over time. And the final velocity is the velocity at the end, while initial velocity is the velocity at the starting point. And so if we make V the subject of formula from this equation, find that final velocity will be equal to initial velocity plus acceleration times time. So this is the equation number one, which I've called the equation number one. This is a very important equation. At times you can be asked any of these and you should be able to rearrange the equation in that manner. The second equation is actually stated as follows. Average velocity is equal to final velocity plus initial velocity over time. Here we are looking at actually the mean of these two velocities. That is the velocity at the end plus the velocity at the starting point divided by 2. And we also know that average velocity is equal to actually displacement over time. S here stands for distance or displacement over time. And therefore, since average velocity is equal to final velocity plus initial velocity over time, and it's the same as actually displacement over time. So you can equate this. And so this is what we have done here. We have equated uh, displacement over time is equal to final velocity plus initial velocity over time. And so from here, we can make the S or the displacement the subject of formula, and it gives us actually final velocity plus initial velocity over 2 multiplied by the time. This is what we have called as the equation number 2. When we are asked to find the distance, and we actually know the final velocity and initial velocity, as well as the time, can be able to calculate the displacement actually. And so third equation, we can derive it from equation number 1 and equation number 2. Remember, in equation number 1, we said final velocity is equal to initial velocity plus acceleration times time. And in equation 2, we said actually average velocity is equal to actual displacement over time, which is equal to final velocity plus initial velocity over actual 2. And so we have these two equations. So where there is final velocity, we can actually place it with initial velocity plus acceleration times time. So this is what we have done here. This is where there was final velocity. And if you add u plus u, it gives us 2 times initial velocity plus acceleration over time over 2. We have merely arranged this. And here we still know that actually displacement over time is equal to 2 initial velocity plus 8. So acceleration times time over 2. Here we have eliminated what you wanted to eliminate is the final velocity. So we have replaced this final velocity with this one here, initial velocity plus acceleration times time. We put it there. And this is what it gives. Now, if we make t a subject of the formula, we are going to multiply 2 times displacement. It gives us this one. And then t multiplied by everything. So we're going to have 2t plus acceleration times t squared. Okay, so this is what it is. Therefore, from here, now we can actually divide here with the 2, and here's the 2. Let this 2 go, and here's the 2. And it gives us the third equation where we're saying displacement is equal to initial velocity times time plus half times acceleration times t squared. So this is an important equation that we need to know. And we have known how to derive it, how to come up with it. Then next we look at equation number 4, where we say final velocity is equal to initial velocity plus acceleration times time. Remember, this was our equation number 1. And so if you squared both sides, this equation number 1, where we're saying final velocity is equal to initial velocity plus times. So if you squared both sides, we're going to have b squared and the whole this is squared. And if we expand this one, actually what we get is u squared plus 2u times acceleration times time plus acceleration squared t squared. And from here, actually, we can factor out 2 times acceleration. So if we put here 2 outside, it means that here are going to remain initial velocity times time plus for if we since we have 2 here, for us to remain with the 1 there, it means that we have to put half. So that when you multiply 2 times this one, it gives us 1. And so then here I've remained with 1 acceleration, since here we have 2, we factored out 1, and then t squared remains. And remember, this equation is the one actually we found here. This is the same as this one. And therefore, where is this quantity here, we can substitute the displacement. So this one here is similar to the equation number 3. Therefore, I can substitute it with the s. And therefore, our final equation will be final velocity is equal to initial velocity squared plus 2 times acceleration times the displacement. This is equation 4. And so this is very important because these equations, if we know exactly how to derive them, it helps us to easily understand even the application. But at times you can put them to memory so that it does not give you that rigorous way of again deriving these equations. You can just know them as first of all, equation 1, as we indicated, is actual final velocity is equal to initial velocity plus acceleration times time. The second equation is this one. Displacement is equal to final velocity plus initial velocity over 2 multiplied by time. Then the third equation is actually displacement is equal to initial velocity times time plus half multiplied by acceleration times t squared. And then the fourth equation is actually final velocity squared is equal to initial velocity squared plus 2 times acceleration times the displacement. And so I thought this is very important for us to understand as we are going to apply these equations to solve many equations. And so we just have one question here that we can actually solve using one of these equations. A bus accelerates from rest to 30 meters per second. What it means here, it is coming from rest, meaning that the initial velocity is 0, and it has gone to the final velocity, which is 30 meters per second. And the whole journey has taken 20 seconds. You calculate the acceleration of the bus and the distance it covers during this time. And so acceleration, we know that is final velocity minus initial velocity over time. And we identified that 30 meters per second was actually the final velocity minus the initial velocity was 0 because it was starting from rest. So meaning that something is not moving at all. Okay, and then divided by 20, and we get actually 1.5 meters per square seconds as our acceleration. Second part of the question was asked us to actually also calculate the distance it covers during this same time. And so we can get one of these equations. We can get equation 4, where we say displacement is equal to initial velocity multiplied by time plus half times acceleration times time squared. And so we said actually the bus was starting from rest, meaning that the initial velocity is 0. And then we know that the acceleration was 1.5 and our time is 20 times 20, which gives us 300 meters. And so I thought we can derive these equations as well as do a simple question to enable us to fully understand actually how to apply these equations. And so continue actually subscribing to my YouTube, and I wish that next time again when we look at another interesting lesson, you follow through. Thank you.